Okay, so this one is an attempt at mathematical induction, the proof by mathematical induction. There's two types. One is divisibility proofs, so which we will look at now, and the other one is your straight, like a linear or a power one. But we'll have a look at this one first. The question is, prove that 6 to the power n plus 4 is divisible by 5. Using this method of mathematical induction. Now normally you will be given a condition. Sorry about the shadows, please ignore, but normally you're given a condition of, say, you need to prove it for n in elements of, let's say, positive integers. Okay, so that would mean your n is equal to 1, 2, 3, 4. What does this mean? It means that you could choose values of n and show that this expression, the answer, comes out to be a multiple of 5. Okay, so notice I'm saying multiple of 5 because if any number is a multiple of 5, it is also divisible by 5. So I want you to think about that. So say, for example, 15 is a multiple of 5, or you could say 15 is divisible by 5. It means the same thing. So ideally, what one would do is you would go n is equal to 1, because this is the set of numbers that n belongs to. So positive integers are your whole numbers, so n is equal to 1, 2, 3, 4, 5, and so on. So you'd sit here and you'd go put a 1 in here and see if it's divisible by 5, show that, put an n is equal to 2, n is equal to 3, 4, 5, and so on. And very quickly you realize that you can't be here all day. These numbers are infinite and they will not, it's not practical to sit here and just do that. So mathematical induction gives us a tool to be able to do this. So what we do, like I normally start this, and there are many ways of doing this, but one of the methods is, I normally go, what am I required to prove? I rewrite this proposition that 6n plus 4 is equal to 5m, where I'm going m is an element of, let's say, natural numbers. So m is just another number, and therefore what this means is 5 times m. So this thing here is a multiple of 5. So 5 times a number will give me this. That's what I'm trying to prove. The first thing I will do is prove proposition is true for n is equal to 1. So we'll try and show that when we choose n is equal to 1, this whole thing is divisible by 5. If you put n is equal to 1 here, so it'll become 6 to the power 1 plus 4. This, you'll realize, is 10, and I know 10 is same as 5 times 2. So I've shown that 10 is a multiple of 5. In fact, when you multiply 5 by 2, you get 10. Okay, so therefore this is divisible by 5 when n is equal to 1. So we will say, therefore, true for n is equal to 1. Now, again, going back to it, like the next one would be n is equal to 2. However, what we do is we say for n is equal to k, which becomes your second step. So you substitute your n to be k. You have 6 to the power k plus 4 equals 5m. So we're not really proving anything here, but we say for n is equal to k, for any number k, this is what your proposition looks like. Okay. Now, the next step is probably the most crucial one. If you could prove that n is equal to 1 works, n is equal to k, that's your proposition, and for any number n is equal to k plus 1, then you have proven this statement. So we'll go prove proposition is true for n is equal to k plus 1. Okay, so we'll try this. Now this is where it gets a little bit tricky. Okay, my next step is I will go and use my initial one here, or you can use this, and go for n is equal to k plus 1. This expression looks like 6 is equal to k, 6 to the power k plus 1 plus 4. Now I am trying to show that this is equal to, or this is a multiple of 5. Realize that this expression here is the same as 6 to the power 1 times 6 to the power k, because the bases are same and you can add the powers, and therefore I'll get that. Why do I do this? Okay, that 6 to the power k, you have seen this somewhere. So the goal is that in this step, you will use your previous step to prove that that expression is a multiple of 5. The way I do it, and there are many ways of doing it, I go back here and I go and realize that, see how this 6 to the power k appears here? There's a 6 to the power k here as well. I go and rearrange this equation to get 6 to the power k by itself. So 6 to the power k is equal to 5m minus 4. I use that to substitute in here. So I get 6 into, okay, 5m minus 4 plus 4. Now be careful not to do this first, because your multiplication comes first, which is your order of operations. So I would expand this out. You get 30m minus 24 plus 4. This is equal to 30m minus 20. Okay. Now we are remembering that we are trying to show that this is a multiple of 5. Therefore, we're trying to show this is a multiple of 5, and I think it's becoming quite obvious now that if you factorize this, 6m minus 4, we have proven that this expression is a multiple of 5, because this m is just a natural number. Okay, we've done it here, sorry. M is a natural number, so therefore this is a multiple of 5. So you can write down, therefore true for n is equal to k plus 1. And the final step is you write your conclusion, and it depends on how you write it, but I normally write it like this: since proposition is true for n is equal to 1, n is equal to k, and n is equal to k plus 1, it is true for n in element of positive integers, which is what we initially began with. So go over this. The process is exactly the same. I think this step 2 here, where you rearrange, can be useful to you.